Hello you guys, welcome to 1.5 multiplication patterns. The essential question is how can you use a basic fact and a pattern to multiply by a two-digit number? Here's the steps. And this one is very, very important. Use your multiplication facts. This is why multiplication facts are so important in 5th grade. If you don't know your multiplication facts, you need to be practicing them every single day. So know your multiplication facts. The second is count the zeros. So let's show you what I mean. We have 6 examples. We're going to go ahead and get started. Alright? Example number 1. 300 times 20. So we're going to look at the whole numbers. That's going to be the main thing you're going to look at here. Okay? And the whole numbers tell me that 3 times 2. Let me see if I can. There we go. Okay. Tell me that 3 times 2 equals 6. And when I count the zeros, I see that there are 1, 2, 3 zeros. So I need to have 3 zeros here. And my answer is 6,000. Right? So you look at the whole numbers, 3 times 2, which is 6, and you count the zeros. I have 3 zeros here, so I need to have 3 zeros in my final answer. Alright? For example 2, it's the same thing. 5 times 8 equals 40. Right? And then how many zeros do I have here? Well, let's count. 1, 2, 3, 4. So I need to have 4 zeros. 1, I'll put a comma there, I didn't mean to. 1, 2, 3, 4. And I see that my answer is 400,000. Now you might be saying, Mr. Brown, there's 5 zeros there though. Aren't there only 4 zeros? Yes, but remember, we originally got 8 times 5, which is 40. So that's why there's an extra 0, because 8 times 5 equals 40. And then when you add those 4 zeros, it makes it 400,000. Alright, examples 3 and 4 are the kind that you're going to see for most of your problems today. And it's fill in the blank. And I think these are important because I want you to see the patterns. Okay? So let's look at the patterns together. Once again, you need to know your multiplication facts. They're very, very important. So let's go ahead and... I don't know why my pen's not working. Give me 1 second. There we go. Okay? It says 6 times 5 times 10 to the first power, which is the same as 10. Well, I know 6 times 5 is 30. And 30 times 10 is the same as, I have 2 zeros, it's the same as 300. Alright, so I still know 6 times 5 is 30. 10 to the second power is 100. And I want you to stop for a second and I want you to say, okay, I know that 30 times 10 is 300. I see that there's 3 zeros in here, right? 1, 2, 3. How many zeros are going to be in my answer? What's my answer going to be? So hopefully you found out that 3 times 1 is 3. And there's going to be 3 zeros. So your answer is 3,000. Now for the last part of the problem, it's the same thing. 6 times 5, which is 30, times 10 to the third power. Now, if 10 to the first is 10, 10 to the second is 100, we know 10 to the third power means there's going to be 3 zeros, so 10 to the third power is 1,000. And if you see the pattern here, you see that there's 4 zeros. Your answer is going to be, well, 3 times 1 is 3, and you have 4 zeros, so it's going to be 30,000. Now you might have noticed, all that happens is that it increases by 0 every time. So as the exponents increase, right, the zeros increase. Okay? Let's go ahead and let's do example number 4. Now example number 4 is the same thing, except now you have to find out what's the 10 spot. These are all going to be 10 to a certain power, so they're asking you to find it. Alright? Well, I know 3 times 7 is 21. And 21 times something is 210. Well, I know that there's only 1 0 here. So it's going to be 10 to the first power, or 10. Because 21 times 10 is 210. So I'm going to put 10 to the first power. And we know that these are all going to be 10s. I just want to know what the exponent is. For the second part, there's 2 zeros here, so it's 10 to the second power. And here there's 3 zeros, so it's, you guessed it, well actually, I'm going to let you pause for a second and think, what's the exponent going to be here? Alright, hopefully you guessed it, it is 10 to the third power, because there's 3 zeros there. Okay, 10 to the third power. So, all that you're looking at here are the zeros, right? The 1 zero shows it's 10 to the first power. 2 zeros here show that it's 10 to the second. And the 3 zeros here show it's 10 to the third. Alright, we got 3 more problems. They're going to look complex, but I'm going to talk you through them. Okay? The first problem is, Yosemite National Park has 2 times 10 to the third visitors per day. How many visitors do they get in a week? Well, I know 2 times 10 to the third. I know the 3 here tells me that there's going to be 3 zeros. 1, 2, 3. And I know that 2 times 1 is 2. So my answer is 2,000. Because 10 to the third power is the same as 10 times 10 times 10. Alright, 10 times 10 times 10 is 1,000. So that's going to be my answer. Oh, sorry about that. Alright, so I just multiply 2 times 1, right, which is 2. And I know that there's 3 zeros here, because that's what that exponent means, 3. And that gets me 2,000. And this is why you need to know your multiplication facts, so you can multiply the whole numbers. Alright, example number 6. Jenny studied a bee that is 30 millimeters long. If she uses a magnifying glass to magnify the bee by 4 times 10 to the second power, how long will the bee appear to be? So this first part, studying the bee that's 30 millimeters long, I don't think we really need to know that information right now. Okay? I don't think that's what we're going to use our equation for. So, it's going to ask us the final length, but we don't need to worry about this right now. Okay? So it's 30 millimeters long. Actually, I'm sorry. It looks like it's not important information, but it actually is. Sorry about that. I meant to say is 30 millimeters long looks like it's something that we don't need, but it actually is something we need, because what we're doing is we're going to do 30 times 4 times 10 to the second power. That's going to show us the final length. So the bee is actually 30 millimeters long, but when we magnify it, we're going to find out how long it's going to appear to be. Okay? Now I'm going to use associative property here. I'm going to put this in parentheses. I'm going to find out what is 30 times 4. Well, 30 times 4 is going to be 4 times 0, 0. 4 times 3 is 12. So it's going to be 120 times 10 to the second power. Now I know that's the same as 120 times 100. And when I do that, I know I have 3 zeros. So 12 times 1 is 12, and I have 3 zeros. So the B is going to appear to be 12,000 millimeters long. So, sorry that I said at the beginning that this didn't seem like important information. It actually is very important information, because it tells you the original length of the bee. So make sure you're looking at all the numbers, okay? Let's go to the last example. The last example says, if the average person loses 8 times 10 to the first power strands of hair a day, how many strands would they lose in 9 days? So you're going to take 8 times 10 to the first power times 9. Now I'm going to use commutative property of multiplication to put 9 in front of 8 and then multiply it by 10 to the first power, which is the same as 10. Now I know that 9 times 8 is 72, and 72 times 10, 72 times 1 is 72 still, and then you add the 0, 720 strands. This is why the properties are so important, and this is why your multiplication facts are important. Okay, it helps make the problem easier. Alright, you guys, that's it for today. Thank you for watching. Please, if you have any questions, make sure to write them down. And you guys have a good one today.